Grade 5 Math, Topic 8, Lesson 5. This is a quick review on how to multiply two fractions. To multiply the fractions, you multiply the numerators across and the denominators across. This worked example is going to take you step by step. 7 times 2. So I fill in the 7 multiplied by 2. 8 times 3, I fill in the 3. 7 times 2 is 14. They did 8 times 3 is 24 for us. Now, they have these two boxes at the end here because 14/24 is not in its lowest terms, and we need to simplify it. So I have to look for a number that I can divide into 14 and 24 with no remainders that's the same. I can divide by 2 on the top and on the bottom. 14 divided by 2 is 7. 24 divided by 2 is 12. So just to make sure, I need to check, can I simplify 7/12 any further? Since 7 is a prime number, I can only break it down by 7 and 1, so I know that I cannot divide 12 by 7 and not have a remainder. So 7/12 is its simplest form. Here's another example. I have 11/12 times 2/5. So I multiply across the top, I multiply across the bottom. So I am going to get 11 times 2, which is 22. And then I'm going to get 12 times 5, which is 60. So once again, I have to look, can I simplify this fraction any further? I can, because 22 and 60 are both even numbers. So I'm going to try dividing by 2 first. So 22 divided by 2, 60 divided by 2, because whatever I do on the bottom, I do on the top. Whatever I do on the top, I have to do on the bottom to keep it equivalent. So 22 divided by 2 is 11. 60 divided by 2 is 30. So now I look again, can I simplify this any further? I have 11. 11 is a prime number, so only 1 and itself is what it's divisible by, so I cannot simplify it any further to not get a remainder. So my answer is going to be 11/30. Here's one more example. This is putting together, adding two fractions, and then multiplying it. I have my parentheses, so I have to do what's inside the parentheses first. And remember, I have different denominators, and we reviewed this last week. We cannot just multiply across the top here because I have to change this into equivalent fractions with the same denominator to even be able to add them. So I have 1/2 and I have 1/3. So I have to have a denominator that's the same for both of these. So I list the multiples out, 2, 4, 6, 8. Let's see, 3, 6, 9, 12. Do they have anyone in common? They do. 6 is in common. So my denominator is going to be 6 for both of these fractions. So 3 times 2 equals 6. I do that on the bottom. I have to do that on the top. 1 times 2 is 2. So my new equivalent fraction to 1/3 is 2/6 that I'm going to be working with. So 2 times some number gives me 6. 2 times 3 is 6. What I do on the bottom, I do on the top. 1 times 3 is 3. So my new equivalent fraction to 1/2 is 3/6. So now I have 3/6 plus 2/6 is 3 plus 2 is 5/6. Now I bring that back up here to my multiplication problem, and I have 5/6 times 8/9. It's back to multiplication, so I can multiply the numerators, and then I multiply the denominators, and I simplify if I can. So 5 times 8 is 40. 6 times 9 is 54. So now I need to look, can I simplify this any further? I can, because 0 and 4 are both divisible by 2. So I have 40 divided by 2, which is 20. I have 54 divided by 2, which is 27. So now I have 27s. Can I simplify this any further? So I can't divide by 2 again because I have 7, which is an odd number, so that's not going to work. I can do, let's see, think of 3. Nope, 3 is not going to go into 20 evenly without a remainder. So this is actually in its simplest form, in its lowest term, so my final answer is going to be 20/27.